Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 12J Part 1 assignment. Okay, first one we're going to take a look at here is consider the following data sets. Set A and set B show that each data set has a mean of 8. Which data set appears to have the greater spread? Explain your answer, and then find the population variance and standard deviation of each data set. Use technology to check your answers. We're actually going to use technology to find this because you can, in the notes I show you how to do population variance and standard deviation by hand, but it's so much quicker and easier with the calculator. And since you get to use a calculator on your tests, we're going to just jump straight to that. So, the mean of 8. So really it's going to be what? 10 plus 7 plus 5 plus 8 plus 10. See what that all equals. Divide it by 8. No, 1, 2, 3, 4, 5. Divide that by 5. And that will give us, should end up giving us 8, right? 17, 22, 32, 40 divided by 5 is 8. Same thing here. Add these all together. 1, 2, 3, 4, 5, 6. And this has got 6 numbers. So that's what? 16, 26, 27, 37, 38, 42, 48. 48 divided by 6 also gives us 8. So we have done A. Which data set appears to have the greater spread? Spread means which one's more spread out. That's definitely going to be these because it goes from 1 up to 14, whereas this only goes from 5 to 10. So B, set B, let's call it set B. It's got a great, we can say greater minimum and like a lower minimum and a higher maximum. We can go with that. The numbers are just way more spread out too. Okay, and then C, find the population variance and standard deviation of each data set. Use technology to check your answers. We're going to just go straight to using technology in the first place here. So we're going to go into data. If you have anything in there, you'd want to hit data again and clear whichever list you want. Or actually, if you scroll down, it will clear all, and it'll get rid of all the data in your lists. Okay, I'm going to do 10, and we're just going to enter all these numbers in here into the first list, and then since we're here, we might as well enter all the data into the other list as well. 4 and 12 and 11, 14, 1 and 6. Okay, and that looks good because we know we have one more piece of data in this second list, so it looks good there. So we're just going to go back and do second data, which is statistics. And we want to do just one variable statistics. We're just going to find the statistics on each data set individually. Okay, so data for the set A is in list 1, and the frequency is just 1. So we push enter, enter, and then calculate. And it's going to give us all the important information. And basically the one that we're going to do is we're actually going to come up with the standard deviation first. And then from that, we can go back and find the population variance second after that. Okay, so we go down, and there's standard deviation 1.897. So for C, standard deviation 1.9, can't remember what I said, 1.897. Okay, so forth and so on. Now to come up with the population variance for that, what we do is normally we find the population variance first and take the square root of that to get the standard deviation. So we're just going to take this 1.897 and square it. Okay, so 1.8974, let's do this, 3, 7. The more digits you come up with here, the more accurate your answer will be. Okay, so standard deviation 1.89737. So then I'm just going to simply do second quit. There's another way to do this, but it puts your data into the table, and that just gets messy. So we're going to just do this by hand. So we're going to do 1.89737 squared. And that gives us 3.6 is definitely going to be our population variance. Okay, and that's actually displayed in the notes and stuff from the textbook. It's O, standard deviation squared, which makes sense that you would square root it to come up with your standard deviation. Okay, so that is number 1. Let's see what number 3 has for us. Ages of members of an Olympic... Oh, wait, sorry. Got to go back because we did not... That was just for A. We got to do the same info for set B. So this is set A. So set B, we will do the same stuff for. We already put the data in there, so we do second data, and we're going to do one variable stats. Now here's where it's different. We got to go over to list 2 now to change our data list. So we'll do list 2, highlight that, push enter, enter, calculate, go down to standard deviation 4.6547. Oops, let's do it down here. 6547 is our standard deviation. And then our, oops, that's not what I'm trying to do. The population variance, that's what I'm trying to say. That's simply going to be 4.6547 squared. 4.6547 squared gives us 21.67, we'll call it, is the population variance. Okay? Okay, now off to the next one, which is number 3. Ages of members of an Olympic water polo team are as follows. Calculate the mean and population standard deviation for the group. Okay, so let's just start with that, and then we'll look at the other parts as we go. So we're going to want to put our data, make our life easy, put our data into the scientific calculator. So remember, like, we got a bunch of old data in there, so I'm going to push data again. If I go down to 4, oops. If I go to 4, it says clear all. It'll get all my data out of there. And then we just start entering our information in there. 22, 25, 23, 28, 29, 21, 20, and 26. Okay. No, that's looking for the 9th piece of data. 1, 2, 3, 4, 5, 6, 7, 8. So we have all the data. I'm just going to kind of go back through and double check to make sure they all look good. They're all in the 20s somewhere. So, okay, that looks good. Now we're going to, it says they want the mean and standard deviation. Okay, so second data, stats. Mean is, oh, sorry. First, got to go back to list 1. Frequency is 1. Calculate. Here we go. The mean is going to be the X with the bar over the top, 24.25. So 24.25 is our mean. And then the standard deviation is going to be, look down here. It's usually, I think, on number 4. Come on, there we go. 3.07, we'll call it, is the standard deviation. Okay. Now, part B says the same team members are chosen to play in the next Olympic Games 4 years later. Calculate the mean, population, and standard deviation of their ages at the next Olympic Games. So basically, the only thing that's going to change is all of their ages are going to go up by 4, right? So all of these are going to go up by 4. That will not change our standard deviation. Remember, that's how, like, the average distance away from the average, for the mean number. Sorry, that's the average distance away from the mean of your data. So really, the only thing that's going to change is our mean now is going to go up by 4 years, right? Because it's going to be 4 years later. So for part B, we're going to get our mean is 28.25, and our standard deviation will be 3.07 still. Okay. Part C, comment on your results in general terms. So again, the only thing that's going to go up is your mean is just going to go up by exactly 4 years because everyone will be 4 years older. But the standard deviation is not going to change because the data group is all, it's got the same distance apart for everything. Okay? Taking a look at number 8 here, 2 baseball coaches compare the number of runs scored by their teams in the last 10 games. The Rockets and the Bullets. Show that the 2 teams have the same mean and range of runs scored. Okay. We're going to eventually have to do the standard deviation. So let's just put this straight into the scientific calculator and away we go, right? So we are back to data, and we only have stuff in list 1, so I'm just going to clear list 1, and I'm going to put all the data in the Rockets into list 1 and the Bullets into list 2. Okay? Okay, so here's all the data put into the scientific calculator under the data piece here. Show the 2 teams have the same mean and range of runs scored. So second data, 1 variable stats. We're figuring out the Rockets first. List 1. Frequency is 1. Calculate. Our mean is 5.7. So A, Rockets, mean is 5.7, right? And then our range, if you actually, you can, it's pretty easy to figure that out. We can just go 0 minus 11, right? If the data happen to be a little bit more confusing, you could always go down to find that the minimum is 0 and the maximum, oops, I went too far, and the maximum was 11, which we can see pretty easily there. So we will do 11, well, 11 minus 0 is just going to be 11, right? And then for the Bullets, let's see, the range here is 12 and 12 minus 1, right? So the range, let's do this. 11 minus 0 is 11, and this can be 12 minus 1 is also 11. And then we can go back into the calculator. Oops, second data. We're going to do 1 variable stats again, but we want to make sure we go over to list 2 because now the data that we want for the Bullets is in list 2. And find that. And look, there's our same mean at 5.7 there as well. Okay? Which team's performance do you suspect is more variable over the period? Check your answer by finding the population standard deviation for each data set. So more variable, I don't know. Well, first one, like at the beginning, these guys have got all sorts of, a lot of variance, but then it's getting a little bit more consistent here. And then at the beginning over here, they're kind of low, but then they kind of started to go back up here. I don't know. That's kind of a tricky one. You can go with whichever one you want, really, on that one. I'd probably go, gosh, I don't know. I guess I'd go with this one because, look, they're never, except for at the beginning, they're pretty close together, but then everything changes by at least 3 or 4, except for this one right in here. Anyway, let's check by doing our standard deviation for each set. So we currently have the B data up here. So the standard deviation for that is 3.29. Standard deviation is 3.29. And then the standard deviation for the Rockets one, we're going to have to go back. Probably could have done that while we had the data up there, but that's no big deal. It's all still in there. So we go back, second data, 1 variable stats. We want to go back to list 1, calculate, and then go down. Standard deviation there's 3.9. So that means definitely that the Rockets have got more of, like, their standard deviation is bigger, which means that that's the average away. That's the average distance away from the middle number. If you were to randomly choose one of those numbers, so the bigger the number, the more variable it is over the period. Okay. And then C, does the range or standard deviation give a better indication of variability? The range doesn't really tell us a whole bunch about variability, but the standard deviation definitely will. Okay, so standard deviation by a long shot. The range really doesn't tell us much at all about variability. Okay. All right. Take a look at the last one here. Okay, 12. The column graph shows two distributions. By looking at the graphs, which distribution appears to have a wider spread? We'll definitely say that data set A looks to have a wider spread, right? And then it says find the mean, the average of each set. So really this 10 and 6, those average out, 7 and 9 average out. So our mean on this one is definitely 8. We can go through and calculate it, but you can definitely tell this 4 and 12 are going to average out. 11 and 5 average out. 6 and 10, 9 and 7. So this mean here is also going to be 8. So set A and set B, the means are both 8. And it just so happens because it's a nice perfect bell-shaped curve for each one of these here. So these will, like the 7 and the 9 will average 7 plus 9 divided by 2 will average out to be 8. 4 plus 12 divided by 2 is going to average out to be 8. So that's just kind of a quick way to show our mean. Okay, but if you wanted to do this on your calculator, you could do, we can do, how about this? Let's do this one over here because it's a little bit quicker and less painful. So if we want to do that, we do data. We got to get rid of all that stuff out of our data list. So we'll do clear all. And then we can say, let's move this over a little bit so we can see the frequency. So we know that the value of 6 has got, oops, I guess we're just going to have to go down. So we'll do 6, 7, 8, 9, and 10. 7, 8, 9, and 10. Right? And then over here we can do the frequency. So 6 happens twice. 7 happens 6 times. 8 happens 9 times. 9 happens 6 times. And 10 happens twice as well. So then we can go second data. Now this is just still one variable. So we hit one variable stats, even though we put stuff from this info in 2 different columns. It's just that our data now is in list 1 and our frequency is in list 2. Because if you remember, list 2 we had 2 6s, 6 7s, 9 8s, and so forth and so on. So you go over here to list 2, push enter, and then go to calculate. And then now it's going to tell us, look, there's our mean, x equals 8. Okay, so it's kind of a way to check it. That's another way you can do that on the calculator, and I believe we're going to do more of that stuff here in the next half of this assignment. So anyway, if you have any further questions on any of this, please feel free to ask in class. Thanks.